on to our next topic here. I'd like to introduce Júlia Souza, and she's talking about endemism and connectivity in fire corals.
So can you listen to me, all you guys? Okay. Louder? I've never... Now.
Okay, then. So, good afternoon. My name is Júlia Souza. I'm a PhD student at the Universidade Federal de Santa Catarina here in Brazil. And my talk today is about the endemism and connectivity of fire corals, genus Millepra, in the tropical Southwestern Atlantic. This work was developed together with Nunes, Carlos Silverberg, and Alberto Nunes. So there are nearly 800 species of reef-building corals throughout the world, and they occur in tropical shallow waters of the globe. Within the Atlantic, there are 81 Scalactini species, or hard coral, the hard corals, and there are 7 milleporid species, the fire corals. And together, these species occur mostly in the Caribbean, and in a few lower numbers in Brazil and West Africa. And most of these species are restricted to only 1 or 2 regions. A few of them, only 10 species, are widely distributed in the 3 regions. And among Scalactinian, 6 of these species have been studied recently, and the patterns showed by genetic evaluation of these corals have shown that the Amazon River plume and the Mid-Atlantic barrier constrain the dispersal and distribution of these corals throughout the Atlantic. And among milleporids, there have been some studies within Caribbean and within West Africa, but in Brazil, we still don't know exactly, actually nothing, about population structure of fire corals. So in Brazil, we have 4 species of fire corals, which are 3 endemics. They are Millepra laborelli, Millepra nitida, and Millepra brasiliensis. And they show different range size, with Millepra laborelli being the most restricted one, occurring only in the northern portion of the coast of Brazil. And Millepra nitida and Millepra brasiliensis occurring sympatrically in the northeastern and southern portion of the coast. There is also an amphi-Atlantic species, Millepra ossicornis, which occurs not only in Brazil but also in the Caribbean and West Africa. But as I said before, we still don't have data on population structure of these species within Brazil, and also about the role of the barriers, possible role of the barriers, such as the plume of the Amazon Orinoco River. That this river, there's a great discharge of low salinity waters, expanding through 2,000 kilometers, and sediment that could constrain the dispersal of these corals, but we still have no data on this. So for this reason, we investigated the phylogenetic relationships and the phylogeographic patterns of these 4 species in order to verify their patterns of population structure and to test the influence of different biogeographic barriers. And to achieve this goal, we sampled 273 colonies of the 4 species in 17 sampling sites throughout the tropical Atlantic, including Caribbean, Brazil, North Atlantic, West Africa, and Mid-Atlantic. And what we found, based on phylogenetic analysis of 16S gene, is that we could confirm the identity of the 4 species, and we found that they form a clade. And here we have a group only formed by the amphi-Atlantic species, Millepra ossicornis, and another group formed only exclusively by the endemic species. And differently from the literature, which states that Millepra brasiliensis and Millepra nitida occur sympatrically along the Brazilian coast, we have found strong evidence of allopatry among these species. The clades formed by each one of these two species correspond to individuals sampled in different regions that are divided by the plume of San Francisco River. This river then probably restricted the distribution of Millepora brasiliensis to the north and of Millepora nitida to the south. And then we provide the first evidence of the role of San Francisco River plume as a regional barrier for the dispersal of reef corals. And what about the interspecific patterns then? Considering both two endemics, we see with the haplotype network here that both species show almost no haplotype sharing among populations, and evidence then of low connectivity among them. And this is further strengthened by data on pairwise FST, which shows high levels of genetic differentiation among populations of both species. And considering the Amphi-Atlantic one, Millepora cornis, here we have the haplotype network, and focusing only on Brazil here, we see there is a contrast with the endemic species, because there's a high star phylogeny with high connectivity among populations of the whole coast. And this also contrasts with the regions of Caribbean and West Africa. And we have hypothesized that this could be due to three main ecological mechanisms, which are long-distance dispersal achieved by rafting, large colony size enhancing the reproductive output of these species, and the generalistic behavior of the species in terms of using the substrate. We have, as this species bears a limited dispersal ability, this is hardly could explain the dispersal, high connectivity and dispersal along the Brazilian coast. But although this species is widely spread throughout the Atlantic, we see here that there is no haplotype sharing among populations of the regions of Caribbean in pink, and West Africa here in yellow, and Brazil in green, showing that there's low levels of connectivity or even lack of connectivity among these regions. Here, the AMOVA data shows a strong proportion of variation due to difference among groups, among regions. And the pairwise FST also shows a strong differentiation among the three regions and low differentiation within regions. So we have also provided further evidence to the role of the Amazon River plume and the Mid-Atlantic barrier in constraining the dispersal and distribution of these Amphi-Atlantic species. And to conclude, at the wide scale, we have seen the role of these two barriers in constraining the dispersal of the fire corals. And at the regional scale, we've seen that San Francisco River may act as a barrier to the endemic species, and that there is a contrasting in population structure among endemic fire corals and the Amphi-Atlantic fire coral. And the take-home message then is that both regional and wide-scale biogeographic barriers have shaped the evolution and biogeography of reef corals from genus Millepora within the Atlantic. So I'd like to thank all the people that helped to develop this work. This was part of my master thesis. And all the funding sources that helped to develop it too. And thank you for your attention.
Any questions?
Do you have any?
Yeah, what other barriers besides, it seems like you were talking about low salinity river, rivers as being barriers for continuous population distribution. What other barriers are there for
what other barriers that could...
Yeah, do you have any idea of the other barriers for dispersal?
There is this one, the Amazon River is related to the low salinity and sediment. But the Mid-Atlantic barrier is relates to the extension of the stretch of open ocean along both sides of Atlantic. So I consider this a different kind of barrier. I don't know if I could answer your question. Another kinds. I can't remember any in the marine.
So I have to doubt if there were ecological differences on like where some of these species are settling. Are some of them like really close to the coast, some like clear water? So are the endemics in any like have any ecological differences to the generalists?
Yeah, in terms of using the substrate, you see.
Exactly.
Yeah, they occur along the same area, but the endemics, what we see in the field is that they occur only in more natural areas. And the Amphi-Atlantic can occupy more impacted zones.
So in a sense, the generalist can resist turbidity of the water, can handle water turbidity a lot better than the endemics.
Yeah.
Okay.
I have a question. Probably you explained it, but sorry about that, if you explained it, but what is the mechanism to explain the starlight, the green starlight haplogroup, suggesting probably bottleneck or this introduction of the...
No, it might be a sign of range expansion in the coast. We have also made some calculations on the age of composition of the population here, but it didn't present. And it's very recent, kind of in maximum 8,000 years.
Still some time left. Anyone has other questions?
When you say 8,000 for, because I don't know if you know, but the South Francisco River, it's this position that you can see today is recent. So in the past, it used to run toward the north. So that's also an agreement. You would expect that they are very recent, because if they are old, you would see both populations. Like, similar position, right?
I don't have age on San Francisco River formation here.
But they already know that in the past, they run towards the north.
At the Amazon or the San Francisco.
So these curve that they separate the two populations, it's something that happened very recent. So if your population is like recent, that's very in accordance to the rivers.
Mm-hmm.
So
It's two different species, isn't it?
Yeah.
You have to see the divergence are.
Yeah, I don't have the divergence time data to show this when it actually happened. So I couldn't calibrate my phylogeny, so I don't have this information. Sorry. Anyone?
Okay, thanks very much.
Thank you.